Let's model international trade between the United States and Japan using two goods, cars and food. In 1 month, both can manufacture exactly one car, but in agriculture, the U.S. yields 2 tons of food compared to Japan's 1. On the surface, the U.S. has a clear advantage in food production and is tied in car production. Figuring out how these two countries should trade requires us to look past raw output and calculate what each country actually gives up to produce these goods. To find that out, we calculate the opportunity cost. There is a simple, foolproof rule for setting up this math. The quantity of the good you want to produce must always go in the denominator. Let's apply this to the United States. If we want to find the opportunity cost for one American car, the car is our target good. We put the one car in the denominator and divide the sacrificed 2 tons of food by it. The math gives us an opportunity cost of 2 tons of food for every car produced. If we reverse the goal and want to produce 1 ton of American food, the 2 tons of food drop into the denominator. Dividing the one car by those 2 tons of food means every ton of food costs the U.S. exactly half a car. Finding these internal numbers gives us the cost structure for a single nation. To see where trade flows, we have to put these numbers against a trading partner. Now, take a moment to calculate the opportunity costs for Japan. Remember the rule: put your target good in the denominator. Because Japan produces 1 car and 1 ton of food per month, the math is straightforward. The opportunity cost for 1 Japanese car is 1 ton of food, and the cost for 1 ton of Japanese food is exactly 1 car. Now we compare the costs side by side. Japan only gives up 1 ton of food to make a car, which is cheaper than the 2 tons the U.S. gives up. The U.S. only gives up half a car to grow a ton of food, which is cheaper than Japan's full car. The law of comparative advantage is built entirely on these final fractions. A country will specialize in and export the good where they hold the lowest opportunity cost. We can see how this theory plays out in the real world by looking at this source material. These pie charts capture a survey of economists grading the impact of trade between the U.S. and China. The top chart reveals a unanimous consensus. 100% of the surveyed panel agrees that importing cheaper, foreign-assembled goods improves the overall welfare of Americans. But the second chart introduces a critical caveat. When asked about domestic workers who directly compete with those imports, 96% of the panel agreed that those specific groups suffer financial hardship. For instance, while cheaper imported clothing benefits consumers at the register, domestic U.S. garment workers face direct wage and employment pressure from overseas manufacturing facilities like this one. This is a standard nuance in economic theory. Free trade successfully grows the total national pie, but it inherently redistributes the slices, creating specific domestic winners and losers. Let's review the mechanics. First, when calculating opportunity cost, your target good is always the denominator. Second, trade direction is strictly determined by those calculations. A country must export the good where its opportunity cost is the lowest. Finally, watch out for the welfare trap. An increase in total national welfare does not guarantee an increase in welfare for every individual citizen. Passing your exam means holding both ideas at once: the mechanical math that dictates trade flow and the resulting reality for the worker.